that there'll be kind of a new kind of computer that will be sent to this problem. What is that idea?
So there's the biological route to intelligence, where every brain is different, and we have to communicate knowledge from one to another by using language. And there's the current AI version of neural nets, where you have identical models running on different computers, and they can actually share the connection strengths, so they can share billions of numbers.
This is how we make a bird.
Yeah. So they can share all the connection strengths for recognizing a bird. And one can learn to recognize cats, and the other can learn to recognize birds, and they can share their connection strengths, and now each of them can do both things.
Right.
And that's what's happening in these big language models. They're sharing. But that only works in digital computers, because they have to be able to do identical things. And you can't make different biological brains behave identically, so you can't share the connection strengths.
But why wouldn't we stick with digital computers?
Because of the power consumption. You need a lot of power. It's getting less as chips get better, but you need a lot of power to do this. To run a digital computer, you have to run it at such high power that it behaves exactly in the right way. Whereas if you're willing to run at much lower power, like the brain is, then you'll allow a bit of noise and so on, but that particular system will adapt to the kind of noise in that particular system. And the whole thing will work even though you're not running it at such high power that it behaves exactly as you intended. And the difference is the brain runs on 30 watts. A big AI system needs like a megawatt. So we're training on 30 watts, and these big AI systems are using, because they've got lots of copies of the same thing, they're using like a megawatt. So, you know, you're talking factor of the order of 1,000 in the power requirements. And so I think there's going to be a phase when we train on digital computers, but once something's trained, we run it on very low power systems.